Hi, welcome back to the Power of Model Drawing. Today we are going to look at fractions, on how we draw out fractions, right? How do we draw out a problem with fractions inside? So let's look at practice problem 1. Now, Mrs. Tan baked a total of 400 cookies. She gave 2/5 of the cookies to Tom. Now, you see the fraction there. So when you want to draw a model, you have to know how to break out the fraction. But before you break out the fraction, what does this fraction refer to generally, right? Generally, like some of you will tell me that 2/5 represent the cookies that he gave to Tom. Very good, which is a very specific answer. But in general, this 2/5 refers to what in general? It refers to the cookies in general. Okay, I'm talking about generally. All right, so that is important because if in some problems you will have more than one fractions. So if the fractions refer to the same group, which you will see over here, you can plus and minus them. You can make the denominator the same. But if the fractions do not refer to the same group, then you cannot plus and minus them. And that is the area where many students make a lot of mistakes, right? Because when they see fractions, they just plus minus. Every time they see fractions without realizing that fractions may not refer to the same group or same type. So let's look at 2/5 again, and generally it refers to the cookies. So if you break up to draw the model, it means that the cookies has total 5 boxes, and 2 boxes are given to Tom, right? Alright, so you're going to use that to draw the model later. And then there's another fraction, and she gave 1/4 of the cookies to her friend. So a second fraction. So what does this fraction refer to generally? So it's very easy to know. You just look at the words behind the cookies, right? So the 1/4 refers to the cookies in general. Okay, yeah, some of you tell me that 1/4 refers to giving the cookies to her friend. Well, that's a very good answer. But Mr. is talking about general, alright? In general, what does this fraction refers to generally? Alright, so it refers to the cookies. And if you were to break up, you can see the cookies has a total of 4 boxes, alright? 4 boxes. And 1 box is given to her friend, which is over here. Alright, now, if these two fractions, if you look carefully, now these two fractions, what do they refer to? Right, the first fraction refers to the cookies, and the second fraction also refers to the cookies in general. So they are both referring to the same group or the same type. So you can plus minus them or make the denominator the same. Alright, but because I want to draw the model, so I will make the denominator the same. Alright, so important lesson here. You have to recognize what the fractions are referring to in general. And if they refer to the same group in general, then you make the denominator the same. So you, what do? You times 4 and you times 5 to get 20. And then on top, you also times 4. And on top here, you times 5. And that is your fraction now. So instead of saying she gave 2/5, now she gave how many? She gave 8/20 of the cookies to Tom, and the arrow pointing is still the same, right? Now the cookies has 20 boxes and 8 boxes are given to Tom, and 1/4 we replace it with 5/20. Okay, all right. Okay, then how do we draw the model? So all the cookies has a total of 20 boxes, but because it's too many boxes, Ms. Dong do not want to cut so many boxes. We can actually just put 20 units, and she gave 8 units to Tom. You cut 1 part and label. So that's another way to put your to draw your model if you don't want to to cut too many boxes. And then she gave 5 units to her friend. So 5 units and friend. Right? And how many cookies did Mrs. Tan have left, which is over here? And that will be how many units? 20 minus 8 minus 5, that will be 7 units left. So you have drawn out the whole problem, or is it? Not really, because you did not put the 400. Right, there's a total of 400 cookies, so you need to put the 400 inside your model. Once you have put everything in your model, then the model becomes your question, and you can use the model to solve without having to look at the question. Alright, so the good thing about model drawing, when you draw out the fractions, your statements will have no fractions. Right, you won't see any fractions. Everything will all be in whole numbers. Right, what do I mean? Okay, let's look at it. Now, for example, you look at the model, you want to find how many cookies left, which we forgot to put the question mark. So you look at the model, and you can see that your 20 units is equal to 400, right? And you can find one unit, which is 400, and then you divide by 20, and there's a shortcut to do this dividing. You remove 1 0, and here also remove 1 0. So 40 divided by 2, that will be 20. So 1 unit is 20. So how many units are left? Which is 7 units. So you have 20 times 7. Also, there's a shortcut to do this. In order 0, you take 2 times 7, you get 14, then put back the 0. So how many cookies are left? Which is 140. Now, if you look at the statements that are written, do you see any fractions inside? No, there are no fractions. They are all whole numbers, right? So that's a good thing about model drawing is you reduce the usage of fractions. It means that when you write out the steps, you seldom see fractions in your equations, right? In your statements. So everything becomes easier to see and easier to write. Okay, all right. So how many left? There will be 140 cookies left, and that's how you draw out the problem. So lesson here, if the fractions are referring to the same group type, you can make the denominator the same. So you need to be able to recognize what the fractions are referring to in general. Okay, general. Okay, now let's look at number 2. 3/7 of the people who attended a party were adults. Alright, half is like a fraction. Half of the children were girls. There were 24 boys at the party. How many people attended the party? Alright, so if I were to ask you what is 3/7 referring to, then you will tell me, oh, it refers to the people who attended a party. They were adults. It's very specific. Alright, your answer is correct, but it's very too specific already. So can we ask, what does this fraction refer to in general? Okay, in general, it's referring to the people. Alright, in general. Okay, the people. Alright, of course, it also represents the adults, right? 3/7 represent the adults. But in general, this fraction is talking about the people, right? It's talking about the people. And then half of the children. So what is this fraction talking about? It's talking about the children. Now there is something very dangerous here. So you cannot plus and minus the two fractions because the two fractions are referring to different group types. Now you can see why pupils make a lot of mistakes. So what they will do is they will take 3/7 and then they plus 1/2 and then they do some subtraction and adding, but it's entirely wrong. Because why? Because the two fractions don't refer to the same group type. That's why it's better to draw the model so that you don't make any careless mistakes. Alright, so how do we draw the model? So the model will look like this, right? So the two fractions, right, they don't refer to the same group type, but can we still break up? Yes. The people has 7 boxes, 3 boxes were adults, right? Same thing. Half of the children, so the children have 2 boxes, 1 boxes were girls. So that's how you break up the fraction. So it's very important that you need to break up the fraction if you are drawing the model. Because if you don't break up, then it's quite hard to draw. Okay, so how do we draw the first sentence? So the people, right? The people, you draw a rectangle, cut into 1, 2, 3, 4, 5, 6, 7. 3 boxes were adults. And of course, the rest must be children. So you have drawn the first sentence. Then you look at the second sentence, half of the children. So look at the 4 boxes on the right side. And can you cut it into half? Yeah, it's quite easy to cut into half. Over here, cut into half. Right, half of the children. So remember, the children must have 2 groups, right? 2 groups, or 2 times, or 2 boxes. So how to cut into 2 groups or 2 boxes? Like this. Okay, so let me just use my highlighter. Alright, cut into 2 groups. Alright, 2 groups. So now you have 2 groups already, or 2 times. And then half of the children were girls, and the other half must be boys, right? And there were 24 boys, okay, 24 boys, all right? So you have drawn out until here. So how many people attended the concert? So your dotted line to show the question mark, and your model is done. That is how your model looks like. So you can see that it's very easy to draw the problem, but unfortunately, many students make mistakes because of the fractions. They will take what do they do? They will take now this is the wrong way of doing, which many of the students will do. They will take 7 over 7, which is everybody, right? Then you minus 3 over 7, right, which is the adult, and then they also minus half of the children, which are girls, and that will give you the fraction who are boys, and that's wrong. Okay, why is that wrong? Because you cannot plus and minus fractions if they do not refer to the same group type, right? 3 over 7 refers to the people, half refers to the children, that refers to different groups, so you can't do that. Right? So I will draw the model. Okay, now so you can see that there are 2 units of boys, so your 2 units will be equal to 24, so your 1 unit will be 24 divided by 2, right? So how many people altogether? That will be 3, 4, 5, 6, 7. 7 units altogether. So there are 7 units of people, so child times 7. And how many people altogether? Answer 84. So once again, you don't see fractions in your equations. Alright, your equations, there are no fractions. So when you draw out the model, the problem, it becomes, the steps are actually quite easy, right? Quite easy to write down. Okay, let's look at the last one. Okay, and okay, now James read 1/3 of a book on Monday and 2/3 of it on Tuesday. So there are 2 fractions again. So what are they referring to in general? So if you tell me 1/3 refers to Monday, okay, it's not general. Okay, it's very specific. So can you tell me what is 1/3 talking about, or what is this fraction talking about? What it's talking about? A book. Alright, it's talking about a book, right? And what does 2/5 talking about? It's talking about it. Yeah. Alright. So it's correct to say that 1/3 represent the book that was read on Monday, right? The pages that are read on Monday, and 2/5 represent the Tuesday, right? Nothing wrong. You're right. But we want to be general. Okay, we want to know what each fraction is referring to in general. So you can see that are they referring to the same group type? Now the word "is" refer to the book as well. So which means that the 2 fractions, they actually refer to the same group type. So which means that you can plus and minus the fractions, right? Okay, so let's make the denominator the same to draw the model. So you have 3 times 5 and then 5 times 3, right? So 3 times 5 and 1 times 5, you get 5 over 15. 5 times 3 and 2 times 3, you get 6 over 15. Alright, and then we draw the model. So the book has a total of 15, right? 15 boxes. And if you think it's too many boxes to draw, then you just put 15 units. And he read 1/3. So we don't see 1/3 already. We look at 5 over 15. So how do we draw out the fraction? Okay, arrow pointing. So the denominator is the book, right? So that is the total parts of the book. And 5 boxes is read on Monday. Alright, 5 units on Monday. So you label. And then 2/5. No more 2/5. You have changed it into 6 over 15. So which means that the book has a total of 15 units, right? And 6 units are read on Tuesday. So you cut 6 units, and this is your Tuesday, right? Tuesday. Okay. Oops. Let me just write a bit nicer. Okay. Let me just erase this part again. Right? To show you how to do arrow pointing. Alright, because you need to be very clear, and you must know how to do the arrow pointing. Otherwise, you will draw the model wrongly. Okay. So how do you break up 2/5? Now 2/5, right? The denominator refers to it. So you have it, which is the book, which is 5 boxes, right? And then 2 boxes point to Tuesday. But because we make the denominator the same, so you don't have to look at 2/5. You now look at 6 over 15. And the arrow pointing is still the same. So the denominator points to the book, which is 15 units now. And the 6 point to Tuesday. So now you have 6 units read on Tuesday. Okay, so you must know how to do the arrow pointing. Denominator refers to the total parts of what it refers to. Alright, so denominator refers to the total parts of the book, and the numerator refers to what happened. Right, refers to the like for example 6 over 15. So the numerator will refers to the Tuesday. Okay, alright, so how many pages left to read on Wednesday? So this is your Wednesday, and that will be 184 pages left to read. Or maybe I should put 184 on the outside. All right, it's up to you how you want to draw, up to you. So how many pages are there in the book? And that is the question mark, and you can solve already. So how do you solve? Now you look at the units. How many units read on Wednesday? So you take 15 minus 5 units minus 6 units, you will get 4 units. So you have 4 units left to read, which is 184. So your 1 unit will be 184, and then you divide by 4. So 184 divided by 4, your 1 unit is 46. So how many pages are there in the book, which is 15 units? So 46 times 15, and you will get a total of 690 pages in the book, and you solve the problem. All right, so again, you don't really see any fractions in your unit statements. All right, sometimes you do have, but usually when you break out the fraction, you don't really have fractions in your unit statements. All right, and it becomes easier to solve, easier to write down the steps. All right, so we come to the end of the model drawing lesson. So for the next several lessons to come, we will continue to focus on how we draw out fractions, because fractions is a very big topic. You will continue to see fractions in primary 5 and in primary 6 as well. So you need to be able to draw out problems with fractions inside. Alright, so we come to the end of the lesson, and I will see you on next Thursday.